Good evening. I am Dharanjayan, working as assistant professor in Department of ECE, SRM Engineering College. Now we discuss about the topic basics of electromagnetic waves. So the electromagnetic is nothing but branch of physics or electrical engineering, which is mainly used to study about the electric field and magnetic field. So the electric field and the magnetic field both are perpendicular to each other and move on to the wave model. So the wave model is initially discussed about by the J.C. Maxwell in 1980s. So the mainly this is for electromagnetic wave radiations. Okay, so the electromagnetic energy or electromagnetic wave, it travels to the free space at the speed of light. Okay, the speed of light is nothing but 3 into 10 power 8 meter per seconds. It's a general one. The constant value speed of light is 3 into 10 power 8 meter per second. So mainly the electromagnetic wave consists of two fields. One is nothing but electric field, another one is nothing but magnetic field. So the electric field and the magnetic field are both are perpendicular to each other in the direction of propagation. So generally the it's a wave model. The electric here in this figure, the electric field is denoted in red color and the magnetic field is denoted in blue color. Okay, with the direction of propagations, the electric field and the magnetic field, it's both are perpendicular to each other, both are perpendicular to each other. Okay, with respect to the direction of propagations. Okay, that means the both electric field and the magnetic field, the both the fields are at right angles to the each other, right angles to the each other, that means perpendicular to each other. Okay, so these are the basic parameters to characterize the wave motions. So the first one is nothing but amplitude, next one is nothing but the wavelength, next one is nothing but the frequency. So the amplitude is denoted as A. So this is nothing but how high the waveform is. Okay, so from the origin or from the DC lines, how high. Okay, in positive direction it has plus A, in negative direction it is nothing but negative A. Okay, so this is the height, how height is there from the origin. Okay, so that's nothing but the amplitude. So next one is nothing but wavelength. It is denoted as lambda. So this is nothing but the distance between the two corresponding points, distance between the two corresponding points, either in peak points or lowest point. Okay, so this is nothing but the wavelength. It is measured in meters. So okay, the wavelength is nothing but the distance between the two corresponding point, either peak point or lower point. Okay. So next one, frequency. So the frequency is nothing but number of cycles of a wave passing through the fixed point per time. Okay, so the frequency is measured in hertz. So next, same thing, wavelength. So the wavelength is the length of one complete wave cycle. It can be measured at distance between the two successive crests. Okay, next two things with the crest and trough. So the crest is nothing but the greatest peak point value. So this point is nothing but the crest. Okay, so greatest peak point value or upward displacement in this cycle. Okay, this is nothing but the crest. Next one, trough. So the trough is nothing but the inverse of crest. That means greatest negative value. So this is nothing but the trough. Okay, this is nothing but the trough. Okay, so this is the basic of transfer wave, that is electromagnetic wave. So mainly the waveform has basic parameters are amplitude, wavelength, So in wavelength we have 2 points, that is one is nothing but crest, another one is nothing but trough. Okay, so this is the wavelength high, how high it is there. Okay, this is nothing but a wavelength. So this is nothing but point between the two positive points. So this is nothing but the wavelength. So the peak point, the positive peak point is nothing but the crest, the negative peak point is nothing but the trough. Okay, so these are the basic parameters in electromagnetic wave. These parameters used to represent the electromagnetic wave. Okay, so this is nothing but the direction of travel. direction of waveform travel. So, as for the definition, the crest is a point on a wave with the maximum value or upward displacement in the cycle. Okay, this cycle is nothing but the one positive one positive wave and negative. Okay, so this is nothing but the one cycle. Okay, in the cycle, the positive peak is nothing but the crest, the opposite of the crest, that means lowest point or negative peak or minimum peak is nothing but the trough. Okay, so this positive, the maximum peak is nothing but the crest. Okay, the maximum value in the waveform is nothing but the crest, the minimum value in the cycle is nothing but trough. Okay, so these are the basic 2 points, crest and trough. So next one, properties of electromagnetic radiations or electromagnetic wave. So the generally electromagnetic wave travel in free space, that is empty space. It travel in anywhere in the free space. Okay, so mainly it's travel, waveform travels through the any substances travel to any substances because it travels in free space. Okay, for example, the sound wave, it can travel to the gas. Okay, free yeah, in the means gas or solid or liquid to pass in order to we hear to the sound, we hear this sound. Okay, it's travel to the any medium. Okay, the mainly the constant value, the speed of light is nothing but the always constant. The constant value is nothing but 3 into 10 power 8 meter per second. Okay, it's the constant value, speed of light. Okay, next, wavelength are measured between the distance of either crest or trough. Okay, distance between the 2 points is nothing but the wavelength. Okay, it is generally measured, it is generally denoted as lambda, measured in meters. Wavelength is measured in meter. Okay, so how do electromagnetic waves differ? Okay, the electromagnetic waves carry different amount of energy. So comparing the microwave and x-rays, microwave carry the less amount of energy. So based on the energy, we discuss about the electromagnetic waves. Here we here the amount of energy carried by the electromagnetic wave, it depends on the wavelength. Okay, that means the shorter wavelength carry higher energy, the shorter wavelength carry higher energy. Mainly we have in the parameters, wavelength and frequency are wavelength and frequency are related parameters. Okay, inversely related. That means lambda equal to c by f, lambda equal to c by f. Okay, lambda is nothing but wavelength, c is nothing but the constant speed of light, f is nothing but the frequency. Lambda equal to c by f. Okay, so lambda and f both are inversely proportional. Okay, if lambda is low, frequency is high. Okay, lambda is low, frequency is high because inversely proportional. So the frequency also tell us about the energy of the wave. If the frequency is high, so the energy also high. If the frequency is high, energy also high. So in this case, wavelength is low. In this case, wavelength is low. So energy is high, wavelength is low. Okay, so generally lambda equal to c by f. So based on the relations, if frequency is high, energy is high. Okay, thank you.